minus 6ab. Brilliant. Then you've got minus 6ab plus 7ab, which is just going to be 1ab. Or you can think of that as just ab. Okay? So if you have a go at 23, so this time you've got two different letters. Remember, you can't add the letters together. So you've got to, yeah, you get 10c. Brilliant. 10c. The only thing is, for the d, is that you've got minus 9d plus 5d. So you've got to do minus 9 add 5, which is minus 4. You get 10c, take away 4d. Okay, so you're really close there. And don't forget you need to have a sign in between them. So it's 10c, take away 4d. Okay, and then for number 24, we've got some equations this time. So when you've got things like x plus 5 equals 11, I would just imagine if I covered up x, what I need to add to 5 to get 11? And that would just be 6. So for the first one, we know x is going to be 6. For the second one, I've got something take away 6 is 8. So there, what would we do to get x? Yeah, brilliant. That's exactly what you do for the first. You do the inverse. So for the second one, you would do 8 plus 6, which is going to be 9, 10, 11, 12, 13, 14. And for C, it would just be 7, take away 3. Brilliant, which is 4. Yeah, the last one's quite easy as well. 12 take away 5 is x, which is just 7. So that's really straightforward. Yeah, brilliant. Okay, so those ones are quite easy. But the ones that you're more likely to get are like these ones. So something like this, right? 2x plus 5 equals 12. So there's actually two steps to this, okay? So the first thing you'd have to do would be to take this 5 over to the other side. So what will that plus 5 become when I take it over the equal sign? Well, the thing is, when you take something over the equal sign, it becomes the opposite sign. So if it's plus 5 on the left, it becomes minus 5 on the right. So we have 2x equals 12 take away 5. So 2x equals 12 take away 5, which is going to be 7. And then what would you have to do to get rid of the 2? Bearing in mind, we're doing 2 times x. So how would I get that 2 down to the other side? Yeah, if you've got to read the email, that's not a problem. I know it's important. Any correspondence you get from them is important. So if you've got to read that first, that's fine. Yeah, exactly. You've got to divide by 2. Brilliant. So we have x equals 7 divided by 2. And we can use a bus stop. 2 into 7 goes 3, with remainder 1. 2 into 10 goes 5, so we get 3.5. That's it. Okay. So if we look at number 26, we're going to do the same sort of thing. I'll zoom out a little bit. So we've got to do pretty much the same steps. It's just different numbers. So we'd have to take the 2 away first. So if we take the 2 over, think about what it will become. So work that bit out, and then see what you would have to do to get rid of the 5. Okay, once you've done that. And then we should be able to get x. Yeah, so I just plug in my headphones and again, there we go. Sorry, can you hear me okay, Josh? There we go. There we go. Okay. Yeah, that's fine. So brilliant. We have 22 minus 2 equals 5x. Yeah. So we can say 5x equals 20. So then how would I get x on its own? So we've taken the 2 over, and that leaves us with 5x. So we've got 5x equals 20. So how would I get x on its own? Sorry about that, Josh. It just disconnected me, but that should be fine now. That's exactly right. We divide by 5. So I'm going to say expand first. So what I'm going to do is do 2. Now, when we expand brackets, we times everything on the inside by everything on the outside. So I'm going to do 2 times 5x. What would 2 times 5x be? 10x. Brilliant. So I've got 10x. And then you've got 2 times minus 3, which is just minus 6. And that equals 24. Okay, so we end up with that equation. And if we solve that, we'll have the answer. So how would you go about solving this equation? So what we'd have to do first would be to get rid of this minus 6. So you'd have to take that over. So if we took the minus 6 over, what would that become? It's going to become plus 6. Brilliant. So we get 10x equals 24 plus 6, which is 30. And then how would I get rid of the 10? Because it's right by the x, like that. So how would I get rid of the 10? Yeah, we'd have to divide by 10. Brilliant. So we'd have to do x equals 30 divided by 10, which is 3. Well done. That's exactly there we go. So now let's have a look at b. Let's expand these brackets first, okay? So we need to do 5 times 2x, which again is going to be 10x. 5 times plus 1 is plus 5, and that equals 50. So to do this one, I would have to take away 5. So I get 10x equals 45. And then I would need to divide by 10. So x would be 45 divided by 10. So what do you think 45 divided by 10 is going to be? That's going to be 4.5. Brilliant. So we end up with an answer there of 4.5. And it can be a decimal sometimes. Brilliant. Okay, so we've done basically most of this paper. This is pretty, I based these questions on, I think, the 2020 paper. So these are we're most of the way through now. So 28, we have a square with a perimeter of 36. They want us to work out the area. Now, they quite like these questions because it's testing if you know perimeter and area. So the first thing to note is that we know the perimeter of the square. Now, how do we get the perimeter of a shape? Well, the perimeter is what you get when you add up all of the sides of the shape. Okay? Yeah, fantastic. Plus all the sides, brilliant. So what we're looking at is when you add up all the four sides of this square, you get 36. Well, the area is what you get when you times the length by the width. You only ever have to times two numbers, unless you've got a triangle where you've got to halve it as well. But what we need to do here is say, well, I've got four sides and they're all the same. And when I add them all up, I get 36. Same. So how do you think you can get what one of these sides is? How could I get one of those? That's perfect. Right, so we do that. That gets us about a mark. So we've got to do 4 into 36, which is 9. So I can put that on my diagram now. Right, one of the sides is 9 centimeters. So how am I now going to get the area? If I know the length is 9 and the width is 9, how am I going to get the area? Yeah, that's exactly it. So we just need to do 9 times 9, 81 centimeters squared. Well, that's it. Well done. Okay, right. So we'll move on to the next bit. So it's the same sort of thing with 29. Okay, so have a go at question 29. Work out what one of the sides is, and then have a go at working out the area. Okay, so that should be fairly straightforward. So have a go at number 29. So let me know if you're stuck now. And then I want to work out the area. 11 times 11, that's brilliant. So that's 121. So that's our area. Fantastic. Number 30 is a bit interesting. Okay, and again, I always think a picture picture's like 1,000 words for these types of questions. So the length of a rectangle is twice its width. So it's then like this. I'm just going to try and sketch it. So the length is twice its width, and the perimeter is 36. So really, that's probably going to be sort of guesswork. You've got to think about what numbers will add up to 36. So we could say 36 is 18 and 18, but we want the length to be two lots of the width. So we can't just have 18 and 18. That's not going. Well, in fact, that's not going to work either, actually, because the whole if the perimeter is 36, right? What is the length and the width? What are these two sides going to add up to? What will those two sides add up to if the whole perimeter is 36? So if we have a look at it, right, the full perimeter, which is what you get when you add up all four of the sides. So if I added up all four of those sides, right, you would end up with 36. So if I only add up, there we go. If I only add up one of the longer sides and the other shorter side, I've only got halfway there. So those two sides will add up to 18, half of 36. So I need two numbers that add up to 18, where one of them is twice the other, okay? So that, to me, looks like it needs to be 12, and so the longer side's 12. What would the shorter side have to be? 6, brilliant, because they will add up to 18. And if I did 12 and 6 again, altogether that would be 36. So I know the length is 12 and the width is 6. How am I going to work out the area? Do 12 times 6, brilliant. So we have 12 times 6, which is 72. So obviously just being careful there to get that last accuracy mark, and we get 72 centimeters squared. Okay, so let's move on. This one's a bit tricky actually, but let's do it. So number 31. So a square has the same area as the rectangle above. What is the length? What is the side length of this square? So first of all, how would I get the area of that rectangle? That's going to be 18 times 2. Brilliant. Which is 36. So the area is 36, and they're telling us that that is going to be the same as the area of a square. So what that means is we have a square with an area of 36 centimeters squared. How could I work out what one of the sides needs to be if I know the area is 36? So it would be 36 divided by 4 if it was the perimeter, okay? But the thing is, the area is 36. So I need to think of a number that when I times it by itself, I get 36. So what number would that have to be? So a number that I times by itself to get 36. It's very close. It's going to be 6 times 6, right? 6 times 6 is 36. The answer would be 6, but you've got the right idea. Then for the next one, a different square has the same perimeter. You'd have to work out the perimeter of the rectangle, which is 18 add 2, add 18 add 2, which is 40. So for the second one, you would have to divide 40 by 4, okay, because they've given you the perimeter there. Right, let's have a look at the next one. So change 8 a.m. to 24-hour clock time. I think that's really straightforward. That's just going to be 0800. So that's probably really easy, Josh. That's fine. But then number 33, so change 0435 to 12-hour clock time. So if it's 0435 in the 24-hour system, that means it's like 4:35 in the morning. Well, actually, hang on. Yeah, so that's just 4:35 in the morning, right? It would be 16. I'll tell you, it would be 16:45 if it was in the afternoon. So in the 12-hour system, it's just going to be 04:35, but you'd have to say AM to tell you that it's in the morning. Okay, that's quite an easy one. Number 34 is an interesting one. So a train leaves a station at 10:06 and arrives at Glasgow at 12:51. How long is the journey? So let's give you a hint for this. So it's 10:06. So how long is it going to be between 10:06 and 12:06? Because they want, yeah, that's just 2 hours. That's easy. Then how much more time, so this time in terms of minutes, is going to pass before we get to 12:51? That's 45 minutes. Brilliant. So, I mean, this is always how I work out these sort of time questions. Got 2 hours and 45 minutes. Yeah, I have to do that. I can't do this in my head. I have to do a little timeline like that. Right, so nearly at the end of this one. So TV program starts at 7:45, ends 50 minutes later. What time does it finish? So you can probably do that in your head, but the trick that I use would be to add an hour and then take off 10 minutes. So if we do 7:45, an hour later, it's going to be 8:45 p.m. So if it's only 50 minutes, it's going to be 10 minutes before that, which is 8:35. So number 36 is a bit interesting because it looks quite abstract, but actually not too bad if you think about the graph. So it's saying to choose the equation of the line that is parallel to the x-axis. So what I would do here is draw some axes for myself, remembering that the x-axis always goes along the corridor and the y-axis always goes up the stairs. And they've given me a number of lines. So I'm going to think about what those lines would look like. So if I want to draw the line x equals 4, I would need to go across to where x is 4, which is about here, and then draw a straight line. Now, can you tell me which axis, x or y, is that red line parallel to? It's parallel to the y-axis. Well done. So that one is not the one that they want. That's not going to work because they want the one that's parallel to the x. Right, the next one, x plus y equals 0. Well, that's going to be this line. Because on this line, if I add up the x value, so let's say that's -3, then that means the y value is 3. They add up to 0. Now that line isn't parallel to anything, so that's not going to help me. The line x equals y looks like it basically means that the x value is the same as the y values, so it looks like that. But what about the line y equals 4? So if I do this in blue, we'll do it in green actually. The line y equals 4, I would need to go up to where y is 4 and then draw a line. Now, what line or what axis is the green line parallel to? That's parallel to the x-axis. Brilliant. So that is the one that we want. Fantastic. Right, so we're really close to the end of this paper, actually. There's just a bit of geometry now at the end. So 37, choose the equation of the line that is parallel to the y-axis. So I'll cross these off. It's not those two. Have a think about what we just did now. Can you see, maybe draw a picture first. Can you see which of those two lines, A or D, is parallel to the y-axis? So don't rush it. Maybe draw a picture first. So if we think about this, right, x equals -2. Let's think about this one first. What this means is we go to where x is -2, which is here. We draw a straight line. Now, which of the two axes is that line? It's parallel to the y-axis, so that's what they want. They want the line that's parallel to the y. So it's going to be that first one. Okay, so it's a little bit confusing because it's got x in the equation. But whenever you've got x in the equation, it's going to be parallel to the y-axis, and if you've got y in the equation, it's parallel to the x. So it's a bit of a strange idea. So if we look at them, A, B, and C are three corners of a rectangle, and you want the coordinates of D. So we need to have another point that will make this into a rectangle. So we could use a ruler to join up the points that we have. And then if you wanted to finish it, it would look like this. So what would be the coordinates of the last corner of D? Yes, got to be 5 and 7. Brilliant. So I put bracket 5, comma 7, close bracket. Brilliant. There's another couple of these problems here. In fact, let me see what else we have here. A couple more of these problems, bit of indices, pie charts, number relations. Okay. Yeah, we'll finish these today, and then basically from next week, then when we come back to school, we'll do the calculator paper that I've made on Maths Watch. I'll print it off for everyone. Here we go. So A, B, and C are three corners of a parallelogram, and we want the fourth corner. So if I put parallelogram, we want to use a ruler. Yep. So I'm going from A and B, so I'll join those up. Different color. There we go, A to B. And B to C. Better color like it. Red's the clearest. Right, so what I would do then is take the line that I've drawn between B and C. Imagine that it's being moved over to where A is, like that. And the line that joins A and B, I imagine that that is moved down to where C is. So what are going to be the coordinates of the missing corner? 2, 2. Brilliant. That's it. So it's just 2, 2. That's brilliant. So we just say, for there, we just say, we've got to plot it actually. So we plot it there, and we would say 2, comma 2. Brilliant. And then we've got one more of these. So it's the same sort of thing. We've got three corners of a parallelogram. What are the coordinates of D? Let's do the same thing here. So same sort of thing. I just get one of my lines. Oh, right, so between A and B, and then C, then what I'm going to do is move this line over so that it joins up with A, and then move the line between A and B down so it joins up with C. And we should now be able to see what the missing corner is. So what would be the coordinates of the missing corner this time? Yeah, 0 minus 2, brilliant. So we just say bracket 0 minus 2, close bracket. And then we just got a couple of questions left. These are on indices. So write the following using index notation. Now all that means is powers. So basically floating numbers. So 2 times 2 times 2 is going to be 2 to the power of 3 because you've got 3 2's. So the second one, that's going to be 3 to the power of what? 3 to the power of 5, brilliant. And they're not actually asking you to work it out, they're just saying write it down. And then C, you've actually got two numbers. So it's going to be 4 to the something times 5 to the something. So what would have to go in the boxes for letter C? Yeah, 4 to the 3 and then 5 squared, brilliant. Then what would we have for D? Yeah, you get 7 squared, and then you get 9 to the 4. Brilliant. Oh, yeah, 9 to the 4 times 7 squared. Brilliant. And don't forget the times in between. That's great. So number 42. So this is like rules of indices, okay? So we've got 3 squared times 3 squared. So that's like 3 times 3 times 3 times 3. So what would that be as a single power of 3? Yeah, that's 3 to the 4. Brilliant. So what you've actually done is you've added the powers. So whenever you times and the big numbers are the same, you add the powers. So with B, you've got 7 times 7 to the 4. So that's like 7 times by another 4 sevens. So that's going to be 7 to the power of what? That's 7 to the 5. Brilliant. And then with the next one, because you're dividing, well, when we times, we added the powers. So when we divide, what do you think will happen to the powers? Yeah, they get taken away. That's brilliant. So we get 10 to the 9 take away 7, which is 10 to the 2. And then for D, you've got 5 here, which is just 5 to the 1. So if you do 5 to the 8 divided by 5 to the 1, you get 5 to the 7. Because again, when you divide, you would take the powers away. But we only take them away when the big numbers are the same. Okay, brilliant. So number 43. So what we want to do here is multiply decimals. So the method that we use is to ignore the decimal point and then put it back in, okay? So we want to do 3.2 times 6. So what I would do there is 32 times 6 first. So that's 12, 18, 19. That's 192. So I need to figure out where is my decimal going to go. So the answer isn't going to be 192. I just know that there's one number after the decimal in the question. So what is my answer going to be? It's not going to be 192. What do you think the answer will be, or where do you think the decimal will have to go? It's going to be, it's not quite 1.92. Have another think about that, because the decimal in the answer is here. And how many places does it have to go back? There's only one decimal place in the question. How many times does the decimal have to go back in the answer? It's just going to go back once, so we get 19.2. Because if you look at the question, it's 3.2, which is roughly 3, times 6, which would be 18. So if we get 19.2, that's quite close to 18. That's quite sensible. So it should be 18.2. So for B, what would I have to do first? Before I worry about the decimal, what calculation have I got to do first? Well, we would do 85 times 2. Well, I can see what you, yes, you're times them by, yeah, I can see what you're doing there. So you're saying do 85 times 2, right? Because that's basically the same as doing 8.5 times 10 and 0.5 times. That's fine. Yeah. So you're saying times everything by 10 or times both the numbers by 10 to get 85 times 2. So basically what you've done is you've times by 100. That's what you've really done. So because you've times by 100 in the question, you need to divide the answer by 100 to keep it the same. So we need to do 85 times 2. 5 times 2 is 10. 2 times 8 is 16, plus the 1 is 17. But the thing is, in the question, you times by 100. So to make the answer the same as what it should be, you divide it by 100 to get 1.7. Yeah, well done. That's really good. Yeah, fantastic. So then with the next one, you would have to do 20. So I think with the next one, Josh, the way you've done it now is you would times the 27 by 10 and the 5.9 by 10. But really, you times by 100. You would have to do 27 times 59. And then you would have to divide the answer by 100. So 6963, no, 7963, 34, 35, 10, 13. So you get 1,593, but that's not the final answer. Question by 100. You need to divide these. You need to divide the answer by 100. So we would just have 15.93. Fantastic. Brilliant. And the last one. So this time you would have to times 0.32 by 100 to make it into 32. But times in 0.16 by 100 to make it into 16. So really, you've times by 10,000, right? 1 with 4 zeros. So we just do 32 times 16, but then you have to divide the answer by 10,000. So 32, 16. So 12, 18, 19, 0, 2, 3, 5. So we get 512. But we need to divide this by 10,000. The decimal needs to go back 4 places. So we have 512. The decimal has to go back 4 times. 3, 4. So we get 0.0512. Okay. Is that one okay? It's always worth quite a few marks times in decimals. Then you've got to do some add-in fractions. So when we add fractions, we need to remember the bottoms have got to be the same, and then we just have to add or take away the top. So 2/7 plus 3/7 is just going to be 5/7, and we leave it like that. So what do you think 5/8 plus 7/8 is going to be? Yeah, you could think about it as a whole and a half. 7, 8, 9, 10, 11, 12. Yeah, you can think about it as a whole and a half, 1.5. That's fine. I was just going to say 12 over 8, but either one is fine. Then C is a little bit trickier because you've got thirds and halves. So what I'm going to do is make the denominators the same. So what I need is a number which is in the 3 times tables and in the 2 times tables. So the lowest common multiple. So what number is in the 2s and the 3s and is as small as possible? 6. Brilliant. So I'm going to make the 3 into 6 by times in by 2. And I'm going to make the 2 into 6. Yes, the LCM. Brilliant. Lowest common multiple. I'm going to make the 2 into 6 by timesing by 3. So what I really have to do is remember the times the top and the bottom by the same. So I've got 2/3, bottom times by 2 to get 6, top times by 2 to get 4. Second one, 2 times 3 is 6, 1 times 3 is 3. So really the question is 4/6, take away 3/6. So what will that be? 4/6 take away 3/6. Just going to be 1/6. That's all it's going to be. Brilliant. So the sort of questions you'll probably get are going to be more like a quarter. Yeah, that's exactly right. The ones that you'll sort of get will be things like 1/1 plus, say, 3/8. So what you'd have to do there would just be to times the 4 by 2 and the 1 by 2. So you'd have 2/8 plus 3/8, which will be 5/8. That's more what we tend to get. Okay, so we've just got a couple more. These are all pie charts. There's some fraction questions here, but I think you're okay with those. So you can try that on Teams. I put all these questions on the Teams for you, and the answers are in there as well. So let me just get it. So I put this document here on the Teams. Just let it load for a sec. There you go. And all the questions are here, but then all the as well. So you can use that to check. So if we just go back to this for a second, this one. Right. Right, we'll have a look at the pie chart. Right, so the table shows the votes of 900 people in the last elections. Complete the table, so they want the angles. So what we'd have to do here is say 360 degrees, that's the full pie chart, is equal to 900 people. This would probably actually be a calculator question. 900 people. That's so much better than people. So what I'd have to do is work out 360 divided by 900, and that would give me how many people would be in 1 degree. So I think that one actually would be a calculator question, actually, to be honest. Just continue with this. Just going to be 0.4. So to get the angles, I would have to times the frequencies by 0.4. But I think that's really more of a calculator question, so we'll leave that one. We'll leave that. That's more of a calculator question. This one's all right, actually. So the pie chart shows how 36 pupils travel to school. Use the pie chart to complete the table. Now, if I remember rightly, by the way, the angle for car is 80 degrees, and the angle for bike is 70 degrees. Yeah. So we can use that to work out the answers. So we have 36 pupils there. Be in the full pie chart. So if I added up all the angles in the pie chart, what would I get? What do I always get? Sorry about that, Josh. Just kicked me off again. So if I added up all the angles in a pie chart, what would that get me? Well, that should get me 360 degrees. So what I can say is 360 degrees is going to be 36 pupils. Yeah, exactly right. So 360 degrees is what those 36 pupils is worth. So that means I can divide by 36 and I will get 10 degrees for one pupil. So every pupil is worth 10 degrees. So if there's 120 degrees for bus, that's just going to be 12 pupils. How many degrees are there for walking? So what is the angle for walking? 90. Brilliant. So how many pupils walk to school, do you think? Just take a guess. Looking at that, how many pupils walk to school? Just 9. Brilliant. So we have 9. How many take the car? That's going to be 8. 80 divided by 10. Then 7 for bike. And if you add these up, they do add up to 36. So that will be a good check. Right. So if we look at number 48. So what we have here, we have an unfair dice, a biased dice. Now, if we want to fill in the table first, right? I want to fill in what this number is. What is the probability that it lands on a 3? Now, to work that out, I need to know what all of the probabilities add up to. So remember, if I have, say, any situation, if I have all of the probabilities that could happen, what do they add up to? They always add up to 1. That's excellent. So they add up to 1. And that's how we're going to get the missing probability. The numbers aren't very nice here, but we can definitely do it. So let's add up all of the numbers that we know, all of the probabilities that we know. So 0.13, 0.05. Yeah, exactly right. So let's do that quick. 0.21, 0.19, 0.3. Just being careful to do it right. So 5, 8, 9, 18. 3, 4, 6, 7, 8. To get 0.88, and then I've got to take that away from 1. I've got 1.00, take away 0.88. Right, can't do 0, take away 8, can't do 0, take away 8, borrow. 9, 2, 1, 0.12, fantastic. So what that means is 0.12 is the chance that I land on 3. I'm rolling the dice 300 times. I want to see how many times it will land on 3 or on 4. So what I'm going to say here is the chance that it lands on 3 or 4 is going to be, well, the chance it lands on 3 is 0.12. Chance it lands on 4 is 0.21. So I'm just going to add them up. I'm going to do 0.12 plus 0.21, which is 0.33. That is the chance that it lands on a 3 or a 4. Now, if I roll the dice 300 times, how do you think I could work out how many times this will happen, that it will land or should land roughly on 3 or 4? What do you think I would need to do with this number that I've circled and 300? It's 33%. Yeah, that's great. So you could say it's 33% of 300. So what I would need to do is 0.33 of means times 300. So we'd have to do 0.33 times 300. So we can think about what we did before. We would do 300 times 33 and then put the decimal back in. So that's going to be 9,900. But the thing is, in the question, we've times 0.33 by 100. So that means you've got to divide the answer by 100. So what do you think the answer will be? How many times will it land approximately on 3 or 4? Well, if we're rolling the dice 300 times, it can only do it 99 times. So dividing 9,900 by 100 gives you 99. Okay. So basically what we did is we worked out the missing numbers. You worked out the probability, which was 0.33, and then we times by how many times you were rolling the dice. And that's how you get the estimated number. Okay, so they quite like that came up like as the last question, or the second to last question. So just to finish off, we'll do this one. So using the information that 45 times 271 is 12,195, write down the value of. So in A, you've got the same numbers, right? So that means we need to have the same digits as the answer. We need to have the 12, 1, 9, and 5. But if we look at the numbers in the question, how are they different to the numbers that they gave us to start with? Oh, sorry about that, Josh. Sorry about that. Right, if there's a network issue, we'll leave it there for now, and I'll just send you my video on this question. Sorry about that. Is using number facts. So we have given that 262 times 76 is 19,912. Work out 26.2 times 7.6. So what I'm going to say here is we roughly, let's do a little estimate, right? 26.2 is roughly 30. 7.6 is about 8. If you do that, if you times those, you would get 240. So the answer to the question needs to use the digits 19912. It needs to use the same digits, but it needs to be roughly 100 and, it needs to be roughly 240, sorry. So using these digits here, you need to use all the digits. What number can we make that is closest to 240? So you've got to use all the digits, you've got to put the decimal point in to make it as close as you can to 240. What number would that be? So what we should get is 199.12 because that is the closest number I can make using all of the digits to 240 to the estimate, okay? And then for 2, we can do the same thing, okay? So the top of that fraction, if I wanted to estimate this now, 19,912, that would be 20,000. And 7,600 is going to be 8,000 if I wanted to estimate it. we could cancel the zeros, giving you 20 over 8. Now, 20 over 8 is going to be 2.5. So I now need to use, and I'm going to tick off the digits I need to use. I've used the 19912. I've used that, and I've used the 76. So the only digits I can use are 262, those 3 digits. My answer needs to be as close as possible to 2.5. So I'm going to have 2.62 so that I use all 3 of the digits. Okay. So do you want to go through a similar one to that, James? Or is that okay? I can make another one. Let's get another one. That's fine. Hang on. Find my thing, number relations. This one might not be relevant, actually. No, let me change that. I'll just make one up, I will. There we go. So let's say we know that 14. Actually, I'm going to make up a little bit more of an exotic one. Let me change that. So 146 times 23. Right, so I know that so given that 146 times 23 equals 3,358. Using that fact, we want to write down, let's do 14.6 times 2.3. And B, we'll do what do I do for B? Yeah, so they've done, okay, so we'll do that. There we go. So we'll do these two. Okay. So firstly, 14.6 times 2.3. So I want to write down what that's got to be. Now it needs to use these digits here. It needs to use exactly the same digits because we've got 146 times 23 is 3358. So we have used in the question the 14, the 1, 4, and the 6, and the 2 and the 3. So it needs to have exactly the same digits as the right-hand side. So to work out where the decimal needs to go, I'm going to do an estimate. So I've got 14.6, which is about 15. No, sorry, I'm going to say that's about 10. And then 2.3 to one significant figure is 2, giving me 20. So I know I'm going to have the digits 3, 3, 5, and 8, but I need to decide where the decimal needs to go. And it needs to make my answer as close as possible to 20. So where do you think the decimal would have to go? Or if you want to write down the number, you can. Because I need to use all of these digits, but my answer has to be as close as possible in size to 20. Yeah, brilliant. It's going to be 33.58. That's going to be the answer. Very good. And then for B, it's the same sort of idea. I'm firstly going to estimate. So I've got, 3,000. On the bottom, well, the 4 tells the 1 to stay as it is, so it's going to be 1,000, giving me a nice answer of 3. So looking at the question, for B, we know from the question we have 146 times 23 equals 3358. Now, I've used in the question the 3358 and the 146. I've used those. So my answer needs to use the digits 2 and 3. but it needs to be numerically as close as possible to 3. So I know I'm going to have the 2 and the 3. Where would the decimal have to go to make that as close as possible to the number 3? Yeah, exactly, 2.3. So that's what my answer would be. Brilliant. That's great. How do you feel about that, James?